Here we are with linear and exponential functions 4.9. So let's get going on this one. So the first things we're doing are we are just evaluating equations given our values. Okay, so we just plug values in. So negative 3. So y equals 17 times negative 3 minus 28. 17 times negative 3 is negative 51 minus 28 is negative 79. Okay, then if we plug 1 in, 17 times 1 minus 28 would be 17 minus 28. 17 minus 28 will give us negative 11. Okay, if we do 4, 17 times 4 minus 28, 17 times 4 would give us 68, minus 28 would give us 40. So I'm just plugging the numbers in. Okay, and we don't really have a pattern going on in here, do we? So we can't really rely on a pattern to help us figure this out. I suppose you could say that at 0, we're at negative 28, and then we're, adding 17 to that each time and count it that way. Maybe we could try number 2 that way. So, 5. 17 times 5 minus 28. 17 times 5 is 85. Minus 28 gives us 57. Okay. Now, let's take a look at number 2. So we're starting at negative 3. So if I'm making a table, at 0, that's where we have negative 3. Then we're subtracting 8 each time, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I go negative 3 minus 8, 1 would be negative 11. Then it would be negative 19 for 2. Then 3, negative 27, 4, negative 35, 5, 6, 7, 8, 9. We'd have negative 75 for our answer. Negative 75. Okay, now was that easier? I don't know, but going in the opposite direction we'd have to add 8, right? Because we're going backwards. So negative 3 plus 8 would give us 5, that's negative 1. Then we keep doing it. So negative 2 would be 13, negative 3, 21, negative 4, 29, negative 5, 37, negative 6, 45, negative 7, 53, negative 8, 61, negative 9, 69, and negative 10, 77. Okay, so whether you think one is easier than the other, it's almost easier to just plug it in, isn't it, with these simple equations, instead of having to really worry about keeping track. And using a calculator helped me do it fairly quickly, but a calculator can help me do the other stuff just as easy. So looking at number 3, we go 1/2 times 9 plus 15. Well, 1/2 times 9 would be 9/2, or 4.5, plus 15 would be 19.5, or 19.5. If I did negative 1, that would give us negative 1/2 plus 15 would give us 14.5, or 14.5. Plug in 14, 1/2 times negative 14 plus 15. Well, 1/2 times negative 14 would give us negative 7. Plus 15 gives us a positive 8. Then negative 26, 1/2 times negative 26 plus 15 would give us a negative 13, plus 15 would give us a positive 2. Alright, now if we're looking at the exponentials, same idea. Okay, negative 3, 6 to the negative 3. Now, if you have a calculator, it's easy enough to go 6 to the negative 3. And we'd get a fraction of 1 over 2/16. There's a rule here with negatives and exponents. You actually turn it into a fraction. Okay, so you'd have 1 over 6 cubed. 6 cubed is 2/16. That's where we get the 1 over 2/16. If we did 6 to the negative 1, that's actually like 1 over 6 to the first, so it's 1/6. When we get to the positives, much easier. 6 to the first is just 6. Anything to the first power is itself. 6 squared, 6 times 6, so that's 36. 6 to the 5th would be 6 times 6 5 times. So type it in my calculator, 7,776. Okay, if we look at number 5 to the 10th, 10 to the negative 3 would really be 1 over 10 cubed, which 10 cubed is 1,000. So it would be 1 over 1,000. To the negative 1 would be 1 over 10. To the 0, anything to the 0 power is actually 1. If you don't believe me, type it in a calculator and put anything to the 0. So to 1, 10 squared is 100, 10 times 10. 10 to the 6th, once again I got to type it in my calculator, and I get 1 million, because it's 1 with 6 zeros after it. Alright, now number 6, we've got a fraction to the power, so this is kind of weird. So 1/5 to the negative 4 would actually flip it around, and it would be like 5 to the 4th, which would be 625. So to the negative 2 would be like 1/5 to the negative 2 is really like 5 squared because we flip our fraction around, so it's 25. To the 0 would be 1. Cubed, 1/5 cubed, it's like 1 cubed over 5 cubed. Well, 1 cubed is 1, 5 cubed would be 125, so it's 1/25. 1 over 120. Hold on. Let's rewrite that. 1 over 125. And to the 5th would be, and you can just type this in, 1 divided by 5 raised to the 5th power would be a really big number. Actually, a really small number, which I don't have. 5 to the 5 would be 1 over 3,125. So a really small number. It's like 0.00032. Really small. Okay, now let's get to that same kind of stuff we've been dealing with. So, evaluate using the formulas for simple interest or compound interest. Given the formula for simple interest, so this is not like the formula we did in class. This is just finding the interest. So how much did it earn? Calculate the simple interest paid. So find the simple interest you will pay on a 5-year loan of $7,000 at 11% per year. So all they want us to do is take this principal, 7,000, and go 7,000 times the rate 11, so 0.11, we always deal with percents, times the time 5. So we put that in our calculator, and all that does is tell us if it wasn't compound interest. Remember, compound interest, it keeps growing as the money grows. This wouldn't be. This wouldn't be giving you any interest. The interest on that 5 years would be $3,850, but that's not compounded in continually, okay, or even yearly. That's just the interest on that one amount of money. Okay, so number 8, same idea. We just go 1,500 times 0.045 times 2, and that's just the interest. That's only the amount you would earn, not your total. So you'd earn an extra $135. Now, we use that to figure this out. So they're giving us all the pieces on this one. We just plug it in like we've been. So 11,000, or is that 11? Oh yeah, 11,275 times 0.12 times 3, and our interest you earned is 4,059. Now what if we have to work backwards? Well, think of it as an equation. 5,100 times 0.04 times t. Well, multiply that out. 5,100 times 0.04 is 204 times t. So 1428, we just divide by 204. So 1428 divided by 204 gives us 7 years. So if we needed to figure out how much we wanted to earn in a certain amount based off the other information, we can do it that way. Same with 11. 93.75 equals 1250 times 6 times R. So 1250 times 6 give us 7,500. R equals 93.75. So we divide by this guy, and that should give us a decimal. So 93.75 divided by 7,500, we get 0.0125, which, move it twice over, 1.25%. Okay, the last one, 54 equals, clear some space, 0.08 times 9 times P. So 0.08 times 9 would give us 0.72P. Divide everything by 0.72. So 54 divided by 0.72 gives us 75 for our principal. So this is just, if you knew how much you wanted to earn, how much you had, and the rate, it tells you how many years it would take. 11, you know what you want to earn, you know how much you have, you know you're going to leave it in 6 months, what's your rate? What rate would you have to get at least? And then the last one, if you wanted $54 earned at 8% in 9 months, you have to invest 75. Alright, now let's get to the compound interest, which is much nicer to deal with. Okay, that's our equation. So 22 would be our principal, our rate is 3.5 or 0.035, and 6 years. So we just plug it in. So A equals 22,000 times 1 plus, or 1.035, you can write it both ways. You can do that, 1 plus the rate in your head if you want, to the 6th. So, or I can type it in exactly how it was, with the 1 plus the rate. Either way works. Type that in, because you'll need a calculator to do these ones, and we get 27,043 and 62 cents. Now, see, here's the difference between this compounded rate and the simple interest. The simple interest, we just have that money, and that money's not being added to over these 5 years and compounded. Okay, whereas if we look at this one, it is. I'm taking this 22, but after the first year, I have more than that amount. Think of what we did in class. Okay, how we added to that amount. And so that's the total amount we earn altogether, including our initial amount. So if we wanted to know how much interest we made, we would just take that amount and subtract our principal, and that would say we actually earned 5,043 and 62 cents. That was the interest we earned off of our initial investment. So our total amount is right there. Okay, that's what it means by the balance after that many years. 14, same idea. We take 4,300 times 1 plus 0.028, that's our rate, to the 15. Type it in our calculator because we let it do all the hard work for us. And we end up with a total balance of $6,506.77. Okay, so we earned, $2,200. Not bad. Okay, number 15. Suppose that when you are 15 years old, a magic genie gives you a choice of investing $10,000 at this rate or $5,000 at this other rate. Either choice will be compounded annually. The money will be yours when you are 65 years old. Which investment would be your best? So we're going to have to do it twice, right? So here's our first. So 10,000 times 1 plus 0.07 for 7%. Now, 15 to 65, that's 50 years, right? So there's our first. Then our second, we only do half as much, but our percent, our rate, is almost double. Same amount of years. So which one do you think is going to get you more money? Well, let's see. Remember that percent means how much we are earning each year. So let's see what we got for both of them. And here they both are. So some of you may say, well, you're initially investing twice as much. But look, we only made it to 294,570, almost 300,000, right? Pretty close. Whereas with the other one, we made 1,445,010. So almost, 1.5 million. I think it's pretty obvious which one you'd rather do. Because of that higher percent, it's going to end up growing quicker. That's over $1 million more just for having that higher percentage rate. Okay, pretty crazy, huh? So obviously, we want to go with that one. Alright, now taking a look at some of these ones, dealing with some equations and substituting. So P is 7, so 7 times Q is negative 3, divided by 6 plus 10. Use order of operations, multiply here, negative 21, divided by 6 plus 10. So negative 21 divided by 6 is negative 3.5 plus 10 gets us 6.5. Okay, 17, 2 for m, so 2 plus 6 for n, times 2 minus 6. So parentheses first, so that would be negative 4. Then multiplication before addition would be negative 24. 2 plus negative 24 is negative 22. Number 18, for b we got 3, so 3 minus 1 squared plus 3 times 5 squared. Now, this one's kind of tricky. Because this whole thing is in parentheses, I would square that 5. It would be 25, so 3 times 25. Inside this parentheses, we deal with that before squaring. So that would be 2. 2 squared is 4, so we have 4 plus 3 times 25. 3 times 25 would give us 75, plus 4 gives us 79. Just follow an order of operations. Y negative 5 times x4 minus 9 times 4 times negative 5. So we start with this part first inside the parentheses. Negative 4 times negative 5 is positive 20. Needed more parentheses, didn't I? Then 9 plus 20 is 29. 4 minus 29, because it's still in parentheses, would give us a negative 25. Negative 5 times negative 25 is positive 125. The order of operations can be kind of tricky when you make it that crazy, huh? Alright, last two problems doing the same type of stuff. So x is 7 minus 7 minus 7. Notice I've got those parentheses. Minus y cubed. So first I deal with that inside the parentheses. So 7 minus 2 cubed is 8. 7 minus 8 is negative 1. So 7 minus a negative 1 would be like plus. So 7 plus 1 would be 8. 7 minus 8 would be negative 1. So kind of a weird one, huh? And the last one, a is negative 2. So negative 2 times 4 to the 4th plus negative 2 times 4 minus 7 squared. So deal with parentheses. That would become negative 3 squared plus, I can also deal with that as well because they're kind of separated. So 4 to the 4th would be 4 times 4 times 4 times 4. It's actually 256. Okay. Now negative 2 times 256 would give me negative 512. And where did that 1 come from? Negative 512 plus a negative 2 times, now negative 3 squared would be a positive 9. Negative 2 times that positive 9 would be a negative 18. Negative 512 plus negative 18 would be negative 530. And there we have it. All that good work done, and we are ready to rock and roll.